Here we are, Math 3, Logarithmic Functions 2.4. So, we're going to do some solving equations. So the idea here is that if I have an exponential with the same base and they're equal to each other, their powers have to be equal to each other. Okay, so kind of here's an example. You have 3x equals 81. We could rewrite 81 as 3 to the 4th, which tells us x would have to be 4. Okay, now they'll get a little more complex, like if we look at 1, 2, and 3. So I have 3 to the x plus 4. I want to get this to a base 3 to some power. So let's start. 3 times 3 times 3 times 3, we should already know is 81 because of that example, but if you didn't, 9 times 3 is 27, times 3 is 81. 81 times 3 gives us 3, 243. So that's really 3 to the 5th. So I'd go 3 to the 5th equals 3 to the x plus 4. Now I have the same basis, so I can essentially eliminate the bases. And we end up with x plus 4 equals 5, subtract 4, and x equals 1. So that would be the answer to number 1. Okay, number 2, I've got 1/2 to the x. So how can I get 8 to match it up? Well, 8 I know is 2 cubed, right? To make it a fraction, I would need to make that negative. Okay? So you kind of could change this one to 2 to the negative x would equal 2 to the negative 3, so negative x equals negative 3, so x would have to equal positive 3. No, negative 3. No, wait, that would be a positive 3, 2 to the 3rd. That's where I went wrong. So then we divide by negative 1, and we get x equals negative 3. Okay, for number 3, kind of the same idea here. And with this fraction, you just want to treat them each separately. So how would 3 become 27? Well, that's 3 to the 3rd, right? Is 4 to the 3rd 64? 4 times 4 is 16. Times 4 again would be 64, so it would be 4 to the 3rd. So together, it would basically be 3/4 to the 3rd would equal 3/4 to the x, so x would have to equal 3. Okay, now that same concept works with logs. That if I have two logs of the same base equal to each other, their inputs would be equal to each other. So here's this example. So they added this one to get it to the other side. I gave them this, which then they could just say x equals 5. So for number 4, 5, and 6, we treat it that same way. So first I would add log base 2 of 13 to both sides. So I'd get log base 2 of x equals log base 2 of 13. So then I get rid of the logs and we get x equals 13. Okay, number 5, I would add log base 2 of 8. So I'd have log base 2 of 2x minus 4 equals log base 2 of 8. So 2x minus 4 would equal 8. We get rid of the logs. Then we solve. So 2x equals 12. Divide by 2. X would equal 6. Okay, number 6. Same idea. I would add log base 2 of 9x. So I'd get log base 2 of x plus 2 equals log base 2 of 9x. Logs essentially I can get rid of. X plus 2 equals 9x. Subtract x. 2 equals 8x. Divide by 8. 2 reduces to 1/4 would equal x. Okay. Now 7, 8, and 9 are a little more complex, aren't they? But we would just log base 10 of 14. I'd times it by both sides. So I get log base 2 or log base 10 of 2x equals log base 10 of 14. 2x would equal 14. X would equal 7, right? Divide by 2. Get rid of the logs up here. Number 8, same idea. Log base 10 of 29. I times it by both sides. So I get log base 10 of 5x minus 1 equals log base 10 of 29. So 5x minus 1 equals 29. Add 1. 5x equals 30, divide by 5, and x would equal 6. Okay, then with number 9, same idea, times by log base 10 of 625. So I'd get 5 to the x minus 2 of log equals log of 625. Get rid of the logs, now I'm down to the exponential. So now I've got to simplify this. Well, 5 times 5 is 25, times 5 is 125, times 5 again, that's where we get 625. So 1, 2, 3, 4. So I'd have 5 to the 4th equals 5 to the x minus 2. Now we can get our answer, and x would equal 6. Alright, so now on these next ones, okay, we're going to kind of simplify here using the rules of expansion and all that, okay, which remember, we've got those rules where log base b of x times y, we can expand that to log base b of x plus log base b of y. That's our product rule. Okay, the quotient rule, can't remember how to spell quotient, maybe that's no, I don't know, would be log base b of x divided by y equals log base b of x minus log base b of y. And then the power rule would be if I have log base b of x to the k would equal k times log base b of x. Okay, so we're going to use those to split up these numbers to get them in one of those three sets. And then once we have those, we can substitute those approximations in and simplify. So let's show you how it's done. So 5 divided by 8 would become log base 10 of 5 minus log base 10 of 8. Log base 10 of 5 is 0.7. Of 8 is 0.9. 0.7 minus 0.9 would be a negative 0.2. And that's what we wanted us to get. Could we have typed that in a calculator and got the exact one? Yes, but we're just practicing. So just a way to practice expansion. Okay, 25. Well, we don't have 25. However, isn't 25 the same as 5 times 5? Or 5 squared? So I could go log base 10 of 5 squared. Then using the power rule, bring that down. 2 times log of 5. Or you could have split it up and went log base 10 of 5 plus log base 10 of 5, you'll get the same answer. So that's equals 2 times 0.7, so that'd be 1.4 for 11. Okay, 12, I'd go log base 10 of 1 minus log base 10 of 2. Okay, remember anything to the log base would be different. Okay, would be 0, right? However, I can also say 1/2 is the same as 8 over 16, isn't it? So I could change that to the log of 8 over 16, which would then become log base 8 minus log base 16. So I get 1.2 minus, 8 is first, isn't it? 0.9 minus 1.2 to give us negative 0.3. Okay, log of 80. Okay, that would be like 8 times 10. So I'd have the log base 8 plus log base 10 of 10. Remember, when we don't write it, it's like there's a 10. And remember what happens with that one when we had the same numbers? Okay, that's like 10 to what power equals 10 to the first. So we know that becomes 1, and then log base 8.9, so we get 1.9. Okay, number 14, 1 over 49. 49 we know is like 7 times 7, but does that help us? It doesn't, does it? Okay, we do know for 1, however, with 1, log base 10 of 1, right, would basically be 10 to what power equals 1? So we know it would have to be a 0, right? So we could go log base 10 of 1 minus log base 10 of 49, okay, and we'd get that to be 0, so I'd have 0 minus log base 49, but what can we do with that using what we know? Well, that would become negative log of 7 squared, so we could make it negative 2 log base 10 of 7. Then I guess we're just assuming. If we look at this, log base 5 is 0.7, log base 8 is 0.9, log base 7 is in between them, so it's probably like 0.8 if we're rounding. So negative 2 times 0.8 would give us negative 1.6. That's what I would go with. Alright, now let's take a look at these next ones. So now we've got log base 3 of 2 and log base 3 of 5. So 16 would be, we would think 4 squared, but it's also 2 to the 4th. So log base 3 of 2 to the 4th, take this 4, bring it down, and that would be 4 times log base 3 of 2, which would be 4 times 0.6, which would give us 2.4. For 16, 108, okay, how can we split that one up? Well, we could go, 108 is 9 times 12, right? That wouldn't help us. Splitting that up. So we could think of it a different way. Okay. So 2 to what power could we get to 108? Well, that we know is 16, times 2 is 32, so 2 to the 5th, times 2 is 64. Well, what about 16 times 5? No, that wouldn't work. That would be 80, plus 16 would be 96. Plus 16. No. That wouldn't work either. So sometimes they can be a bit tricky, can't they? So let's go. 2 to the 7th would be 64, and 64 would be 128, wouldn't it? Alright, so this one's giving us some trouble, isn't it? There's got to be some sort of connection here. Let's see if we divide it by 2. 108 divided by 2 would give us 56. No, 54. Okay. So 54 times 2, if we divide this by 2, 54 would give us 27. That's not helping either. Okay. Because that would be 2 times 50 times 27. But that one wouldn't help us out either, would it? Alright, once again, I think we're going to have to assume a few things. So if I look at this, here's what we can do. Okay, if I went log base 2 of 3, and log base 2 of 4, well, the difference between these two is 0.9. If I divide that by 3, that would give me 0.3. So to get to 2, we'd add 0.3 to 0.6, so we'd have 0.9. And then we'd have 1.2 and then 1.5. So if I do it that way, okay, and approximate those ones, then what I can do is I can factor 108, and I end up with 3 3's. So it'd be log base 3 of 3 cubed times, and 2 2's would be 2 squared. So I'd split that up, and I'd have log base 3 of 3 cubed plus log base 2, or base 3 of 2 squared. So I'd have 3 times log base 3 of 3 plus 2 times log base 3 of 2. Log base 3 is 0.9, so 3 times 0.9, which would be 2.7, plus 2 times log base 2 is 0.6, which would be 1.2. Added together, we get 3.9, which would be our answer. Alright, now let's look at 17. So we have 3 divided by 50. Okay. There's a problem here, isn't there? My thought process was off. That should be 1, huh? Because that's log base 3, not log base 2. So maybe I didn't need this one. Maybe I just needed to realize that anytime we have log base b of that number, it's going to equal 1. So instead of 2.7, we would have had 3 plus 1.2, so that should be 4.2. Or no. 1.2 and 3, yeah, 4.2. Okay. So let's do the, we'll see it in 17. Okay. So I have log base 3 of 3 minus log base 3 of 50. Well, 3, that becomes 1. So I have 1 minus 50. We can split up to 2 times 25. 25 is 5 squared. So 2 times 5 squared would give us log base 3 of 2 plus log base 3 of 5 squared. That 2 would jump down here. This would become 0.6, so 1 minus 0.6 plus this would be 2 times log base 3 of 5 is 1.5, or 3. So I'd go 1 minus 0.6, which would give us 0.4, plus 3 would give us 3.4 there. That's better. Okay, for 18, still need that. Okay, we'd go log base 3 of 8 minus log base 3 of 15. 15 is 3 times 5. So log base 3 plus log base 3 of 5, because I'd split those up. That we know is 1. This is like 2 times 3, or 2 to the third, right? So that would become 3 times log base 3 of 2, which would be 0.6 minus 1 plus log base 3 of 5 is 1.5. So that would give me 1.8 minus 1, which would be 0.8, plus 1.5, which would be 2.3 for number 18. Okay, number 19, we've got 486, so let's split this up. So 2 will give me 243. 243, I should remember, is 3 to the 5th. 3 times 3 is 9, times 3 is 27, times 3 is 81. 1, 2, 3, 4, yeah, times 3. So that would be log base 3 of 2 times 3 to the 5th, which we'd split that up to look like this using our rule. Then using the power rule, it could actually be log base 3 of 2 plus 5 times log base 3 of 3. That would be 1. 5 times 1 is 5. That would be 0.6. So we get 5.6 for number 19. Okay, 20. 18 would be 3 times 6. 6 is 3 times 2. So it would be 2 times 3 squared. So we'd add and bring down. So I'd have log base 3 of 2, which is 0.6, plus 2 times log base 3 of 3, which is 1. 2 times 1 is 2, so we get 2.6 for our answer for 20. Okay, 21. 120, that's like 2 times 60. 60 is like 2 times 30. 30 is 5 times 6. 6 is 2 times 3. So I have 1, 2, 3. So it would be 2 cubed times, or 8, right? Times 5 times 3. So I'd bring this down in front of log, so 3 times log base 3 of 2. Then that would make a plus. Log base 3 of 5, then that would make a plus. Log base 3 of 3. That becomes 1. This becomes 1.5. This becomes 3 times 0.6, which is 1.8, plus 1.5, plus 1, 1, 2, 3, 1.3, so 4.3 would be our answer for 21. And the final one, okay, 32, that would be like, that's 2 to the 5th. 45 would be 5 times 9. 9 is like 3 squared. So we'd have log base 3 of 2 to the 5th minus log base 3 of 5 plus log base 3 of 3 squared. So that 2 would jump down. So I'd have 2 times log base 3 of 3 plus log base 3 of 5. And all that subtracting from that one, which we'd pull down the 5, so 5 times log base 3 of 2. Log base 3 of 2 is 0.6. Log base 3 of 5 is 1.5. Log base 3 of 3 is 1. So 1.5 plus 2 would give us 3.5. That would give us 3. 3 minus 3.5 would be a negative 0.5. And that would be our answer. So, a lot of thinking on this, huh? Okay, now this one, it says, use your calculator and the definition of a log to find the value of x. Okay, so essentially, you are going backwards to figure out what the input would be. Okay, it says to round to 4 decimals. So on these ones, that's log base 10, so it would be 10 to the negative 3 equals x. 10 to the first equals x, so that one's easy. That's 10. 10 to the 0 equals x. That's easy. X equals 1. Okay, 10 to the 1/2 equals x. We'd use a calculator. 10 to the 1.75 equals x. 10 to the negative 2.2 equals x. 10 to the negative 3 would be easy too. That's 1 over 10 cubed. 10 cubed is 1,000. So 1 over 1,000, you just turn into a decimal, which would be 0.001. Okay, but these ones we're going to need to just use a calculator to do, huh? So it would be 10 to the 3.67 equals x, 10 to the 3/4 equals x, and 10 to the 6th equals x. Okay, so I grab out a calculator, and I'm just going to type those in. So 10 to the 1/2 would give me 3.1623 if I round to the 4 decimals. Okay, 10 to the 1.75, that would give me 56.2341. 10 to the negative 2.2 gives me 0.0063. 10 to the 3.67 gives me 4677.35. 10 to the 3/4 gives me 5.6234, and the last one, 10 to the 6th, gives me 1 and 1, 2, 3 and 1, 2, 3, a million. Okay? Alright, that's it, guys.